a particle will be, it'll have a velocity of 0 right there. Okay, so velocity is equal to 0. What about from 0 to 3? How do we calculate its velocity from right there? So we'll say, what's delta t going to be? Let's find delta t for that one. So delta t, we're going from 0 to 3. So delta t is going to, what does delta t equal? It'll be t final minus t initial. So I will have, my final time is 3, my initial time is 0. So that's going to be 3 minus 0. So I'm just going to have a 3 right there. Okay. What about my position now? Is it clear when I write on the screen? Can you guys read my handwriting for on there? Okay. I know it's not maybe the best, but all right. All right. So for delta x, what should we put for that one? So from 0 to 3, what's x? So delta x, my change in position, delta x is going to be my final position minus my initial position. So that'll be x initial. What's my initial position? 7. I thought it was 6, but you're right. So 7 minus 0. Okay, so we've got delta x. We've got our t here. So then our velocity is going to equal, it'll say 7 divided by 3. What's 7 divided by 3? Let me get out my phone. I think it's 2.3-ish. So 7 divided by 3. Oh, it's 2.33. Wow, I was so close. Okay, so that's going to be, my velocity then for the first part is going to be 2.3333333. Do I need to write all those 3s? Why not? How many 3s should I write? Should I write any 3s? 2, Mackenzie, you are absolutely right about that. But could I make this more precise than just 1 digit? Well, let me ask you this. How well do you think you can read this graph here? How precisely do you think you can read it? How accurately do you trust that? So the first point right there, that's a 7, okay? But how close to 7 do you think that value actually is? Well, it's probably, I would say on here, I could probably get within, I could probably read it to like 7.0. I could have 2 significant figures. I feel confident looking at the graph that I could assign 2 significant figures. So I'm going to say, all right, I trust my answer. I'd say probably 2.3 is a reasonable result. So that's, I think I can safely assign that accurate of values. Okay, so I've got 2.3 meters. And what are my units on this? What should my units be? So this one is in meters. Is velocity. So meters per second. Okay, so I found that for this first part here, my velocity is going to be 2.3 meters per second. Okay, so I can look at a velocity graph here, and I can calculate what my velocity is going to be. What's another way, just looking at the graph, when we find that value 2.3, what's another term for that called? So these are just lines. So if you remember from, I think it's pre-calculus or trigonometry, that is actually called the slope of my line. Do you guys remember slope? Okay, so yeah, you can look at this plot and you can find the slope, and the slope of your plot is going to be your velocity. And so you can also think about it as rise over run. Okay, so right here, if my rise my rise right here is 7, and my run is this part right here. So 3, that's my run, and my rise is 7. Okay, so, and it has a positive slope, okay? So, yeah, so that means it's, yeah, it is, yes, positive slope is going that way. Let's take a look over here, and let's look at this region over here, okay? And just from our, so between 11 and 16, okay, so between 11 and 16, what is the slope of our line right there? Just read it off of the graph. What's going to be the slope of our line? Over 7. Okay, so we go from 11 to 16. So we're starting right here. And we go down 1, 2, 3. So we definitely go down 3. How many do we go over? It looks like 1, 2, 3, 4, 5. So should that be 5 or 7 on the or 5? Okay, so we'll rewrite that. Okay. So all right, so it should be -3 over 5, and this will be meters per second. That's my velocity. It's negative. Why is it negative? Where did that negative sign come from? Left, but where does that negative sign come from? So on we are moving up in time, so our delta t is going to be positive, but our position delta x here, because we're going to go our final position is going to be 7, so it'll be it'll be 7, but then our initial position for time there is going to be 10. So delta x is going to be 7 minus 10, which is going to give us -3. Okay, so I'm looking for a car. Okay, did you guys ever do... Oh, here's a car. All right, so here is I think this is a Lamborghini. Oh, I just drew all over the thing. Okay. So it looks like we have a negative velocity there. And what's 3 divided by 5? That is probably 3 divided by 5. Okay, that's going to be 0.6. So that tells us our velocity. So V is equal to minus 0.6 meters per second. Okay, let me erase all this stuff over here because we got too much stuff going on our screen right over here. Okay, so we found our velocity. Okay, now it's negative. So what's happening to the direction of our car? Okay, because in the first part here, all right. Can you see it now? Can you see the marker board now? All right, so for the first part here, when the car goes from 0 to 7 and it's got a positive velocity, it's headed up this way. Then when it goes from 7 to 10, it's also pointed that way. So while it's positive, my velocity vector is going up this way. That means I'm moving away from the origin. When my velocity is negative, the car turns around and it's headed back towards 0. So if I have a negative velocity, it's headed back to the origin. It's going that way. It's moving closer to the origin. It's going more negative in the negative direction. So if it's if the car is my velocity vector, then if the velocity is positive, then it's pointing in the positive direction, and if it's negative, then it's moving in the negative direction. So my velocity is negative, it's moving down that way. It's becoming more negative. Okay. Is there any question? Do you guys have any questions about velocity vectors, or is it all pretty clear? What about acceleration vectors? Well, we haven't got to acceleration yet, but we'll get to that later. Okay, so let's look at number 2. To understand and use proportional relationships, we say that y is proportional to x if they are related by an equation in the form of y equals c times x. Okay, so let's look at this problem real quick, and then I will let you go for the day. Okay, so let's draw a graph here on my figure, and we're gonna just make up some equations, and I'm gonna make my own graphing paper really quickly. I should probably buy some graphing paper, but that's okay. Okay, so here is my graph, and I think it looks pretty good. Maybe not, but okay. So what? All right, and then I'm going to do 0, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so this axis is going to be y, and this axis is going to be my x-axis. All right, so let's write an equation. What would I have? Let's say y equals c times x. What if c equals 1? What would my line look like through that? How would I draw my line? So let's do some points. Let's say if y equals, and let's say c equals 1. So if c equals 1, and I plug in my x value here, so I go to 1. If c equals 1, then my first point is going to be right there. Okay, and let's do another one way over here. Let's say, what if x equals 5, then and c is equal 1? So that means that if x equals 5, then y is going to equal 5. Okay, and so then my line will look like this. Okay, so it's 1 to 1. Now let's do another equation. What if y is y equals c times x and c equals 3? Okay, so if c equals 3, let's do another point here. Let's say, okay, at x equals 2. So at x equals 2 right here. So if I put in a 2 right here, then I'll have 2 times 3. That's going to give me 6. So that means if x equals 2, then y is going to equal 6. Okay, so I have a line right here. And then I need to find at least one more point. So what about if x equals 0? What's y equal? Well, what is it, Jonathan? It's the origin, and it goes up here kind of like this. So now I am my own graphing calculator. Okay, that's awesome. Let's do one more. All right, what if y equals c times x, and this time c equals, let's say, 1/4. Okay, so that means, all right, it also starts at the origin here. So right here, if I say x equals 0, it's going to start at the origin. So I just need to find one more point. So let's choose x equals 4. So if x equals 4, then I have 4 times 1/4, and then y is going to equal 1. So right here, that's going to be my point. And so now I can draw my line like this. I connect my point over here at 0. I have 3 different lines, and I can label this one. I can say c equals 1/4. This one is c equals 1, and then up here I can say c equals 3. Okay, so this is my proportionality constant c, and it tells me this function, and I can plot this function. You can plot it in a calculator. You can do it by hand, just like I've done here. And so we can now use this and say, okay, one really important relationship is, now we could use this and we could say x equals v, so my velocity, times time. Okay, so now what I can do is I can say, well, let's say my velocity is equal to 3, or let's say 2 meters per second. So 2 meters per second. Okay, so now I'm going to draw another plot over here. Okay, I'm going to say, now I've got, this side's going to be t, this side's going to be x. This is my position vector. So I'm going to draw, or that's, yeah, my displacement. Okay, so I'm going to go up here. I'm going to draw another plot here. And if my velocity, okay, so let's say my car is moving at, so v is equal to 2 meters per second, then let's say at t equals 3 seconds, okay, how far am I going to move? So this is 1 meter, 2 meter, 3 meters, 4 meters, 5 meters, 6 meters. So this is my line, 3 meters. And then over here is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, okay? Now I can look at this and I can say, okay, if my car is traveling at 2 meters per second, after 3 seconds, how far will I have traveled? All right, so at 3 seconds, I'm gonna go over here, 1, 2, 3. If I plug a 3 into my equation here, so if I put 3 in there, v is equal to 2. So let's say x will equal my velocity, so 2 meters per second, times my time, so that will be 3 seconds, okay? My units will cancel, so I'll have, my seconds will cancel. I'll be left with meters, so I'll have 2 times 3, so x is going to equal 6 meters. So on my plot over here, 3, then I'll just go up here, and there's my, it'll be 6 meters. And so now I will draw a line here, okay? And so now I can look at this, my plot, and I can say, wow, I know where my car is going to be at all time for the rest of the universe. So after 2 seconds, it's going to be at 4 meters. And after 1 second, it will be at 2 meters. And if I go on here to 4, if I carry on my line, then it looks like it's going to be, oh, it's supposed to be at 8, but, well, okay, my graphing paper is not very good. There we go. It's supposed to be at 8. So if you plot it out, then that will give you the value. So if my other car then, say, has a value of, let's say, 1.5 meters per second, okay, so then at 1, I'll have another equation. I'll have, say, x equals 1.5 meters per second times t. So here's t. So if t equals 1, so I'll go here, then I'll say, so this times, yeah. So this will be, I'll put in 1 second here. So I'll have 1.5 meters per second times 1 second. That'll be my position. So it'll be 1.5 meters. My seconds go away. So it'd be right here. So now I can just take my ruler. I don't need to plot any more points than that because I can draw a line here through the origin, through my point. Okay, and I've got my velocity for all time and space. And if I had better graph paper, it would really be awesome, but I don't. So then at 2 seconds, we should be at 2 times 1.5. So we should be at 3. That should be right about there. And if I had better graph paper, it would really be awesome. Sorry about that. Okay, well, we've already gone over for 7 minutes, but this at least will get you started on the homework for chapter 2. Okay, so you can, of course, plot this on your scientific calculator. Do you guys all have calculators that could plot this for you? Okay, so you remember how to do, work your calculators to do that? Maybe. Okay, well, try and figure this out on your calculator. I always really like to make plots like this. It really, I think that this visual approach really helps you understand the problem. At least for me, it does. Or you can also just plot it by hand. You don't need a graphing calculator. But I always think all the functions that we're going to do, make a plot of it, draw a picture. And drawing the picture, whenever I draw a picture, it really, really helps me to visualize what's going on. So always, always draw a picture. That's something that I always do, no matter what the physics problem is. I still draw pictures. Okay, so any other questions about what we did or chapter 1 or 2? Okay. Well, if nobody has any questions, then and why don't you guys make up your own velocity function and plot 2 velocity functions and send them to me, just like I did. Send me, so plot, make up your own velocity function, draw out a plot by hand, make your own graphing paper, draw your own functions, and send it to me. Okay, so it's fun to draw it. Okay, that way, if you can draw a plot of the velocity, man, you'll never forget it. You'll be like, oh, Dr. Wisby's class had to draw these pictures. So, all right, and the more you understand this stuff, the better it's going to be later when we get to more things going on later. So we're building the foundation right now of our physics castle. When we get to the top, it's going to be amazing. Okay, so yeah, send me some plots of velocity function. So that means x equals v times t. Make your own graph paper, plot them, and then take a picture and send it to me. This will count towards for participation. Okay. So with that, I'll let you go.
Thank you. Like and subscribe down below.